The methodological case study by Ulitsk et al. Directly compared two subgroup discovery approaches, atomistic feature clustering and sequence clustering, across 4 tasks from the PISA 2025 LDW domain to evaluate the generalizability of uncovered behavioral patterns. Both methods revealed highly consistent results, with strong cross-method agreement, chi-superscript 2 values ranging from 126.44 to 239.22, all p less than 0.001. Indicating that sequences jointly allocated to a cluster by one method were significantly likely to be assigned to the same cluster by the other. Atomistic feature clustering identified 2 to 3 clusters per task, while sequence clustering identified 3 to 4, primarily subdividing the longest sequence cluster. For both approaches, membership in cluster 1 characterized by the shortest sequences, median log lengths, 0.69 to 1.62, and shortest times to first action, was most probable when all predictors, task score, prior knowledge, and, for the big challenge, effort, were at their sample minima, e.g., for the big challenge, probabilities of 0.85 for atomistic and 0.84 for sequence clustering, supporting its interpretation is disengagement. Conversely, for the easier learning task 1, cluster 2, medium-length sequences, had the highest probability when predictors were at their maxima, 0.74 for atomistic, 0.71 for sequence, suggesting efficient solution behavior among high-proficiency examinees. However, for the more challenging learning task 3 and big challenge, the longest sequence clusters became most probable at predictor maxima, e.g., big challenge cluster 3 probability of 0.99 for atomistic, cluster 4 probability of 0.72 for sequence, indicating that successful performance on harder tasks required persistence and effort even among knowledgeable examinees. Cross-task stability tracked via alluvial plots showed that cluster 1 membership remained stable across all 4 tasks, while examinees in persistent clusters on learning task 1 often split into medium or long sequence clusters on later tasks, reflecting strategic adaptation to task difficulty. Both approaches identified task score and prior knowledge as significant predictors across all tasks, with sequence clustering additionally identifying perceived difficulty for learning tasks 2 and 3. Self-reported effort was retained only for the big challenge in both methods. Importantly, confidence ratings, preparedness, and emotional states were not significantly related to cluster membership in any task. These results demonstrate that both clustering approaches captured similar, generalizable, and theoretically meaningful behavioral patterns, with the simpler atomistic feature method performing comparably to the more complex sequence clustering approach for this dataset.